So now we're going to look at some VPN technologies, virtual private network technologies, which are basically tunneling protocols that will take data from one place to the other when it has to go through an unsecured network. Now, I said that this is a tunneling protocol. And what is a tunneling protocol? What does that mean? Well, a tunneling protocol just means that it's putting a header and a trailer on some type of data, and it takes it through a network that it doesn't understand. So, for example, let's say we have a Novell network that is two Novell networks that need to communicate, and they're using their own proprietary network stack. Well, the Internet can't understand that. If it's got to go through the Internet, you need a tunneling protocol, which means that it needs to have the necessary headers and trailers that the environment understands. And so it goes through, it wraps basically the packet up, it takes it through the network that it doesn't understand, and then it unwraps and it goes to the receiver. And as an analogy with as a tunneling protocol, there's like in Seattle or different places that they have car ferries where you're actually going to drive your car onto a ferry, and the ferry is going to take you over water. Well, the car itself wasn't developed to deal with or understand water. That's just like protocols. Protocols weren't necessarily built to understand how to work over a certain type of network. So as the ferry analogy, we'll take cars from one place to the other. That's what a tunneling protocol does. It takes the data from one place to the other, and then it unwraps. It takes the encapsulation headers and trailers off, and then it's speaking to a host that understands that protocol that the other computer really spoke in. So there's different types of tunneling protocols. Now, one thing is that tunneling protocol does not mean that you automatically have encryption or confidentiality. So you can have a VPN that has a tunneling protocol that is not providing encryption. It's very rare, but the important piece is that don't assume that a tunneling protocol automatically means encryption. They're different concepts. A tunneling protocol could be used in things that are not referred to as VPN, but the protocols that we do use for VPNs are tunneling protocols. So we'll look at several different types of protocols, technologies that have been used for VPNs, PPTP, L2TP, IPsec, those types of things. Now, PPTP was the first, and it was the de facto standard for VPNs. It's a Microsoft protocol, and it was really developed more for a host-to-host communication instead of like a router-to-router communication, because it only allows like a single communication going back and forth. It can only work over IP. It doesn't have as much granular control or the amount of security that something like IPsec has. So for a long time, PPTP was the de facto. Doesn't mean we're not using it anymore. We are using it. But when we have to connect network to network through a VPN connection, it's usually IPsec and not PPTP. We could use PPTP through computer to computer, or even from your computer up to your ISP or to the corporate network. So PPTP today is usually used host to either host or network, but it's not usually used network to network. Now, there's another tunneling protocol that's L2TP, Layer 2 tunneling protocol. And what Cisco came up with L2F, Layer 2 forwarding protocol, which was an encapsulation protocol working at the data link layer. And then they took L2F and PPTP and basically combined them. That's how we came up with Layer 2 tunneling protocol. So L2TP is really a combination of L2F and PPTP. So what's this protocol about? What are we using this for? Well, I said that PPTP and actually IPsec can only go over IP networks, like the internet can only go over IP networks. But we have other types of networks that we will need to extend our VPN over. We have WAN links that we want to extend a secure connection over. So L2TP can work over IP, but it can work over other types of networks like frame relay, ATM, X.T5. So it just is a capability to really expand upon the PPP. Like if you're having PPTP or IPsec, it'll allow you to expand it through the other networks. Now, L2TP does not have encryption. You can't provide any confidentiality with L2TP. So why in the world would Cisco come up with a protocol for VPNs that doesn't provide confidentiality? Well, the reason that they did that is because IPsec was already developed and it was already out there. IPsec is a de facto standard for VPN technology. So why, recreate the wheel? Basically, L2TP can go across the network and extend the VPN, and then IPsec really plugs into it, and that's where using IPsec will allow you to do the authentication and the confidentiality and those types of things. So L2TP doesn't provide confidentiality or encryption. It has to work with IPsec to be able to do that. This I'm showing the actual L2TP header information. It's encapsulating a PPP segment. So where I said that PPP works at the data link layer, and to be able to extend that PPP connection, that's where you would have the L2P. It extends a PPP connection over networks that it's not IP. So IPsec is the last VPN technology that we'll look at, and it is the de facto standard, which means that's mainly what we use today, specifically from network to network when they need to communicate. Not always from like a host to a network, but that can be set up. Now, we went over IPsec pretty in depth in the cryptography domain, so this should be just a review. So IPsec works at the network layer, and it's the de facto VPN technology, and it can only work over IP networks. So these are definitely information you need to know. So in cryptography, we talked about IPsec can work in transport mode or tunnel mode. And transport mode means just the data payload is protected. In tunnel mode, it means that the data load, the payload, and the headers and trailers are protected. So what a lot of people kind of get messed up there is they always think that protected means encryption. And you can actually have AH, Authentication Header Protocol, which doesn't provide any type of encryption, that can work in tunnel mode. So tunnel mode just means the data, payload, and headers are protected. Now this protection can be encryption if you use an ESP, or it could be protection of authentication and integrity only if you use an AH. Now the CAN definition, which means what you would most likely see, would be that transport mode protects the data payload, and tunnel mode protects the data payload and headers. But a lot of people think that protection automatically means encryption, which is not true. So we did go through the different protocols. IPsec is a suite of protocols. Authentication header is one protocol, ESP is another one. And in cryptography, we talked about the difference, where authentication header protocol can only provide system authentication and integrity. It'll provide integrity of the data payload or the data payload in the header, depending on if it's working in transport or tunnel mode. So if AH is working in transport mode, it's going to basically do like a MAC. It'll create an ICV, integrity check value, over the data payload. And if it's in tunnel mode, it will do that. It will do that over the actual headers. It will create the ICV integrity check over the headers. And one thing we discussed in cryptography was that if your packets are actually going through a NAT device after it's gone through the VPN device, you're not going to be able to properly communicate, because if you have the VPN device that's using AH, which means it's creating its integrity check value over the headers, it goes to the NAT device. The NAT device will change the IP address, and then it goes on to the destination. When the destination does its own integrity check, it'll compare it to the ICV value that was in the packet that came over, and they won't match. So the receiver will think that there was corruption or manipulation in some way. So in ESP will actually not run its integrity check over the network header. So it doesn't matter if you're going through a NAT device or not. So ESP is the only protocol that can provide confidentiality. If you need encryption, which that's mainly what we need for VPNs, then you would use ESP. So AH provides system authentication and integrity. ESP provides system authentication, integrity, and confidentiality because it uses encryption. And they both could work in either transport mode or tunnel mode. So transport mode is just protecting the payload. It's not protecting the headers. And a problem with that is that somebody can actually manipulate the headers and the destination won't know that. It's just protecting the payload. With tunnel mode, it's protecting the data payload and the headers, which means that the destination will actually know if some header information has actually been changed or manipulated by a hacker. So only in tunnel mode will they actually know that a header has been manipulated. Now, again, in cryptography, we covered all of this, and this should be a review, but we talked about security associations. And basically, let's say we have two routers that need to set up a VPN. Well, they have to go through a handshake session, which is agreement on the parameters of the VPN, what algorithm we're going to use, what initialization vectors, what sequence numbers, what encryption, what protocols, what mode. All of this stuff has to be agreed upon between these two VPN devices. So we covered that there's actually two phases that go on. The first phase is to get a key, a symmetric key on both devices, and that happens through Diffie-Hellman. And then once there's a symmetric key on both devices, then the handshake that's going back and forth, all that parameter information is actually encrypted, so it's protected. Now, once this handshake goes on, it needs to store all that data. It needs to store what it agreed upon. And that's what a security association is that if you and I have gone through this handshake and agreed upon how we're going to communicate, I'm going to store it in a security association in a database that's on the VPN device. And you're going to do the same thing. You're going to store what we've agreed upon in your VPN device and in an SA. Now, SAs are directional, which means that you have to have one SA with the parameters of data going out. This is how the VPN is to process the data going out, and an SA for how data comes in. How do you actually process that data? So there's at least two SAs and potentially more for communication. And if I actually send you, after we've set up our whole handshake and we have our VPN configuration, when I send you data over, how are you going to know what your VPN device, how is it going to know which SA to go pull? Well, that's the SPI, that's an index. There's actually a number that's in the header of the traffic that's coming over to your VPN device, SPI, which basically says you need to go to SA whatever, SA2, SA3. And then the VPN device will use all of those instructions in SA on how to properly process the packets that are coming over. So you're going to have a security policy on the VPN, which is just the configuration. The network administrator or security administrator is going to configure what actual parameters can be negotiated and agreed upon. Because if two VPN devices do not have the same parameters, then they can't agree. So for example, let's say your VPN device and my VPN device, if I come over and say, I want to use the AES algorithm, and your system isn't configured to use AES, well, and my system is only configured to use AES, then we can't communicate. But a lot of times there's like a drop-down list. I can go over and say, I want to use AES. Your system can send back, I don't have AES. So then my software will go to the next algorithm. Then I'll send over, I want to talk in triple DES. And your system's actually configured for that. So you'll say, yep, I can talk in triple DES. So those are the things of how agreements of parameters take place. Now the Security Association, they can actually be put together in different ways depending upon what type of security that you need at different ends. So that means you can have an SA that basically tunnels through a different SA. You could have a device, let's say my computer is going to send data to my VPN device using AH. So there's no encryption that's going from my computer to the VPN device. But once it hits that VPN device and it needs to communicate to another VPN device, then it would use like ESP. Now once it gets to the other VPN device and it decrypts it, it could then actually continue an AH tunnel or an AH connection to the receiving computer. So this is how they can kind of be mixed or matched, where you have AH set up between the node and the VPN device, and then it's ESP between the two VPN devices, and then you have you could have AH between the VPN and the destination. It depends on what's required, but if we set that up, what is that providing, that type of example? Well, it's ensuring if my system is connected to the VPN through AH protocol, it's ensuring that that data is not being manipulated until it gets to the VPN. So because AH provides system authentication and integrity, then it goes over an ESP tunnel through the internet. That means it's providing authentication, integrity, and confidentiality. So these are how they can be put together. It depends on what's needed in your environment. So again, some environments will use AH between maybe a server that needs to communicate to a VPN that'll go over the internet. It's usually not an actual node, like an actual workstation. It could be more of the sensitive type of data that's moving through the network, and then it's got to be encrypted when it goes through the untrusted environment.